Hello guys, welcome back to the channel. The paper we are solving today is IGCSE Physics May June 2024 and this is the variant 21 MCQ paper. Now let's start with the first question. In which row are quantities correctly categorized into scalar and vector quantities? Alright, so we know that mass and energy are scalar. Gravitational field strength is not scalar, it is acceleration. And time is scalar, so this is incorrect. Speed and momentum, speed is scalar, momentum is not scalar. Distance and energy, these two are also scalar. So we have to pick between option A and D. Now, if you look at the vector quantities, weight is a vector quantity, yes. Acceleration is a vector quantity, yes. Now let's look at option D. Velocity is a vector quantity, yes. Temperature is not a vector quantity, so statement option D is correct. A will be the correct answer. Next question. Which name is given to quantity of matter? We know that amount of matter is given by mass, so option B will be correct. Next question. A body is moved from place X to Y where the gravitational field strength is different. So you can just assume you're moving a body from one planet to another planet. So we know that mass always stays the same. Mass is the amount of matter, it cannot change. So mass stays the same. Now we know that we have to pick between option C and D. And weight is given by m into g. Since the gravitational field strength is changing, the weight will also change depending upon the gravitational field strength. So mass stays the same, weight changes. Option C will be the correct answer. Next question. Mass of object is given, volume is given, density of the object we have to find. It's a very simple question. You just need to take care of the units. The unit given here is in grams, not kg. So the formula will be density is equals to mass by volume. Mass, you will write it as 2.5 into 10 to the power 3, 10 raised to the power 3 divided by 480. When you solve this, your answer will come out to be 5.2 grams per centimeter cube. Next question. Four objects each have forces acting on them. Which one is in equilibrium? So we know that for equilibrium, the net force should be 0 and the net moment should be 0 as well. In this question, the net force is 0 but the net moment is not 0. This object will start rotating clockwise. So this is incorrect. This is also incorrect. And this is not net force 0. Incorrect. Option A is the one where net force is also 0 and net moment is also 0. So A is the correct one. Next question. A ball of mass m falls vertically and hits a hard surface. Its speed on hitting the surface is v1. It rebounds vertically upwards with a speed v2. So for this, let's define the sign convention. I am taking the downward direction as negative and the upward direction as positive. Change in momentum is given by mv minus mu. Alright. So m into, see, v2 is when it is going upwards. So v2 will be positive minus m into initial velocity is v1 in this case and it is when you are going downwards. So downwards it will be negative v1. So this becomes mv2 plus mv1 meaning m bracket v2 plus v1. Is there a matching option? This is incorrect, this is incorrect, this is incorrect. Option C is the correct one. Alright. These kind of questions are very simple. You simply need to define your sign convention. I am taking now the negative side as the downward side as negative, upward side as positive. So the downward velocity, which was the initial velocity, I took it as negative v1. And the final velocity, which was going upwards, I took it as positive v2. Alright. Next question. A stone is dropped from a tall tower and falls a distance. We have to find the height with which it hits the ground. Alright. We know that mgh will be equals to half into m into v square in this case. M gets cancelled out. So v square is equals to 2 into g into h. So 2 into 9.8 into height is 50. This will be the v square. Let's just check how much this will come out to be. So 9.8 times 50 times 2 is 980. Now the root of 980 will nearly be 31 meters per second. So the correct answer is this one. You simply need to take the square root of 980 and you will get the answer, which is B. Next question. There is a coal fired power generation station. It is generating electricity. Coal is burned and the energy released is used to boil water. The steam from the water makes the generator move. So the generator is moving. There must be kinetic energy. And coal is a chemical, it must have chemical energy. Now they're asking which row gives the name of energy stored in coal and energy stores in moving generator. Coal will be chemical and generator will be kinetic. So option B is the correct one. Now, question number 9. A man puts some ice into a glass of water on a warm day. All right. After a short time, he notices that the ice disappears. Now, we know that since ice is disappearing, it must be melting. And that the water droplets appear outside of the glass. Just think about it. Water is inside the glass. How is it possible that water is forming outside the glass? There is a process called as condensation, which happens when vapors convert into liquid. You must have seen this when you have a water bottle having cold water during summers. You notice the same phenomena that the outside circumference or the perimeter of the bottle that you can touch, that it becomes wet. How is it possible? That is because of condensation. So our answer will be option B. Condensation is taking place here. That is why water droplets are being formed. And since the ice is melting, so melting will also be in the answer. A gas of volume 200 centimeter cube is trapped inside a container by a piston. The piston is pushed to the right, volume decreases, temperature is constant. So this is the key point here. When we know that temperature is constant, so we know that pressure is inversely proportional to volume. Or you could say PV is equals to constant. Pressure is inversely proportional to volume. So if you're decreasing the volume to half, pressure will double. So force per unit area should double, means we have to pick between option A and C. Now, kinetic energy depends upon the temperature. Is there any change in temperature? I don't think so. Temperature is constant. So kinetic energy will stay the same, but the force per unit area, that is the pressure, will double. So option C is the correct answer. Now, this again is a question of the Boyle's law. When temperature is constant, so pressure is inversely proportional to volume. And we all of us know that the inverse graph looks like this, option D. Because at this point, pressure is highest, but the volume is lowest. And at this point, volume is highest, pressure is lowest. So this is a inverse graph. Question 12. During evaporation of a liquid, the most energetic particles escape, right? We know that. Temperature of the remaining liquid changes. Yes. Which row identifies where these particles escape from? See, they escape from surface of the liquid, right? And describe the temperature change. You must have seen the phenomena that evaporation causes cooling. Whenever you are sweating and when you go near a wind source, you feel more cold. You feel a little bit more colder compared to the normal conditions. That is because the particles which got evaporated, they carried some energy. They took away some energy. So if they took away some energy, the energy of the sample will decrease. So the places from which the particles escape will be the surface of the liquid. So we have to decide between C and D. Now, temperature of the remaining liquid will decrease because the particles which got evaporated, they took away some energy along with them. So that is why the energy of the liquid will decrease. Wet cloths are put out on a, alright, so they are simply asking that if you want to dry the wet cloths as fast as possible, so you need a hot day. The sun should be out with a lot of wind. That will be the best pick. So option D is the correct one. Question 14 has been removed from the paper. All right. Question 15. A solar heater is designed to absorb energy. Which surface, texture, and color would be the best solar heater? So they're simply asking you which color absorbs the most amount of heat. It will be dull black. Black is the best absorber. Now, between dull black and shiny black, dull black is the better one. Shiny black will still reflect some because it is shiny, but the dull black will absorb all of it. So option A will be the correct one. White and the vibrant colors, they reflect heat, they reflect the radiation. But the black colors, the darker colors, absorb the radiation. And out of them, dull black is the strongest absorber. Question 16. Which statement about waves is correct? Waves do not transfer energy or matter. This is incorrect. They transfer energy without transferring matter. Waves transfer both. This is also incorrect. Waves transfer energy without transferring matter. This is the correct answer. So option C is the correct answer here. The angle of incidence on a plane mirror is gradually increased. So let's imagine that this is the plane mirror. This is the normal, let's say. So they're saying that the angle of incidence, let's say initially is like this. Imagine this is your angle of incidence, angle of reflection. Both are same. So they're saying now the angle of incidence is gradually increased, all right, to the nearest degree. What is the maximum possible angle for reflection to take place? So what you can do here is the maximum nearly will be something like this. It can be a bit more. So where is this angle going towards? Is this not going towards 180 degrees? Yes. So the answer will be 180 degrees. Which conditions are necessary for light to be total internally reflected? For TIR, total internal reflections, there are two conditions that we need to be aware of. First of all, it always takes place from denser to rarer medium, not the other way around. Only denser to rarer medium. Then the angle of incidence should be greater than critical angle. So angle of incidence should be greater than the critical angle. So we have to decide between option B and D, and the incident light should be in the denser medium. It should be in the denser medium. So option D will be the correct answer here. Denser to rarer and angle of incidence should be greater. Next question. The diagram shows a ray of light. We know that refractive index is equals to sin I by sin R, right? And you simply substitute sin 40 here and sine 30 degrees here, you'll get the answer. The answer will come out to be 1.29. Now, question number 20, they are showing us an optical fiber. We know that TIR takes place in the optical fiber because angle of incidence is greater than critical angle, right? Which statement correctly explains the condition for maximum transmission of light? Now, in all the options, you can see that this part is common. I'm underlining this: common, common, and common. Now, the next part is saying to make the critical angle as large as possible, and in this case, it is saying as small as possible. Now, just think about it. In optical fibers, TIR takes place. So, the TIR should be achieved early for better transmission, right? Now, if you're making the critical angle as 80 degrees, in this case, it will be difficult to reach TIR. Difficult to TIR. But if the critical angle is small, let's say 40 degrees, TIR will be easily possible. So the critical angle should be as small as possible. And if you look at option B and D, both are exactly the same. So you can pick anyone out of B and D. There is some error in this question. Option B and D, you can pick anyone out of these two. Now, Which region of the electromagnetic spectrum is used to detect fake banknotes? Ultraviolet is used to determine the fake banknotes. Now, next question. A sound wave travels at 330 meters per second. The distance between center of compression and to the center of nearest rarefaction is this. See, we know the formula that V is equals to frequency into lambda, but have they given us the lambda here? 2.5? No, this is not the lambda. In sound waves, lambda is the distance between one compression center to the another compression center. Currently, they have given you the distance from this to this, but the wavelength is this to this. So the double of this. The wavelength should be 5 centimeter. And you convert it into meters, so 0.05 meters. Now simply use the formula. V is 330. Frequency we will take as F only. Lambda is 0.05. Now when you solve for this, your answer will come out to be 6600 Hertz. That is the correct answer. 23. Which waves are used in the medical scanning of soft tissue? We know that ultrasound is used for this. Which row describes suitable materials for use in a temporary magnet? Now, this is a good question. Temporary magnets are the ones which, depending upon the need, we can make them a magnet and we can demagnetize them as fast as possible. For example, electromagnets are temporary magnets. When you pass current through them, they become magnetized. When you remove the current, they become demagnetized. So for temporary magnet, iron is used, soft iron, because it gets magnetized easily and gets demagnetized very easily as well. And for permanent magnet, we will use something which retains its magnetism. So that is steel. In our syllabus, there are two examples. For permanent magnet, you use steel, and for the temporary magnet, you always use the soft iron. So option B is the correct one. A magnetic field is represented. They are asking which point shows the strongest. We know that the closer the magnetic field lines, strongest the magnetic field there will be. This in this region, they're the most closer. Option A is the correct one. So this is a question showing that a resistance of R resistance is there. All right. She is using voltmeter and ammeter. So they're just asking that what is the correct way to arrange it. Voltmeter should be in parallel and ammeter is connected in series. Both are connected in series, incorrect. Both are connected in parallel, incorrect. Option C, ammeter is connected in parallel, voltmeter in series, incorrect. Now option D, voltmeter is connected in parallel, ammeter is in series, so this is the correct answer. Question 27. A diode and a resistor are connected. Terminal X is initially positive and at a maximum value, then the potential difference changes. Alright. So now if you look at the graph here, the potential difference graph here, it is showing that initially it is a maximum here, then after some time, after half the time, it is decreasing, then it is changing the direction. So you can just assume if the total time is 2 seconds, for 1 second, the current is flowing from X to Y, and for the second, the current is flowing from Y to X. You can assume it like this, that if the total time is 2 seconds, for the first half, the current is going from X to Y, and for the second half, it is going from Y to X. And initially, it is starting from X to Y. How do I know this? Because they are saying terminal X is initially positive, and current flows from positive to negative. Now, just try to understand this. If the current is initially flowing from X, so it must be going like this. Follow the arrows. It must be going like this. But there is one issue here. The direction of current is not aligning with the direction of diode. And when situations like these arise, current does not even flow. So during the first half, there will be zero current. And is there any option where during the first half zero current is there? No, no, no. Option D is the correct one. As simple as it is. Alright. And after the first half, the current will flow in the opposite direction. So it is going down. Make sense? Alright. When a conductor in a complete circuit across a magnetic field, a current is induced, all right. Which statement about induced current is correct? The induced current is in the same direction. So this question is about the Lenz's law. We know that the induced current or the induced potential difference is in the opposite direction to the change causing it. Whatever change you are trying to do, the induced voltage or the current will be in the opposite direction. So induced current is in the same direction, incorrect. Induced current is in the opposite direction, this is true. But then they're saying direction to the motion of the conductor. No. Is motion of the conductor the only way we can change? No. The direction of the induced current is in the same direction. This is incorrect. The direction of the induced current opposes the change causing it. This is the correct answer. Now, question 29, they're asking you to compare the strength of magnetic field. They have given you 3 points, X, Y, and Z. Now, see, you clearly can see that X and Y are in the magnetic field and the field lines must be uniform throughout. So, X and Y have the same magnetic field strength, but Z has the least one out of them. So y is greater than z, x is greater than z. So magnetic field at y is equal to x, this is correct, equal to x, this is correct. Greater than x, incorrect, greater than x, incorrect. Now let's check the magnetic field at z. Z has the lower magnetic field. Z is less than x and y. So less than x, correct, greater than x, no, less than x, correct, and greater than x, no. So you can see clearly in option A, both the points are correct, right? So option A is the correct one. How did I solve this question? I simply checked that X and Y have the same magnetic field. Z has less magnetic field than both of them. So that is why option A. This question is about a conducting wire placed between poles of a magnet. When electric current in the wire is in the direction shown, the force acts out of the page. Alright. So this question you can solve using Fleming's left-hand rule, which tells you that you can remember the mnemonic FMC. Force, magnetic field, current. So this will represent the thumb, index finger, middle finger. So using the Fleming's left hand rule, let's check these statements. When the current is towards the top of the page, the direction of the magnetic field is unchanged. So the force produced acts into the page. Yes, this is correct. Look at the statement. They're saying that electric current is downwards and the force is acting out of the page. Now, you are only changing the current direction, so the force will also change because the magnetic field is still constant, right? So statement A is correct. When the current is towards the bottom of the page and the magnetic field is reversed, so the force produced acts into the change. All right. So see, you have three variables. Out of the three variables, you're changing one of them and one is constant, so the other one will change. Just give it a try using Fleming's left hand rule. This is also correct. When the current is in alternating, the wire vibrates into and out of the page. Yes, this is true. So option A will be the correct one here. Which type of electric current are in the primary coil and secondary coil? We know that transformer gives you AC current. So option A will be the correct one. Primary coil also uses AC current and the secondary coil also delivers AC current. A scientist fires alpha particles at a very thin sheet of coil and detects the particles that pass through. Which statement about the results of the scattering experiment is correct? Alpha particles are attracted? No, they are repelled. Half the mass of the atom? No, the complete mass of the atom is in the nucleus. Most of the alpha particles are deflected, showing that the nucleus is very dense. Not most of the alpha particles. Only a small number of alpha particles are deflected, but some of these are deflected through large angles. This statement will be the correct answer here. So option D is the correct answer. So they have given you the nuclide notation of gold and they're asking you what is the relative charge. We know that neutrons does not have charge. Electrons are outside the nucleus. They're asking you the nucleus charge. So nucleus contains protons, neutrons. Neutrons have zero charge. How many protons are there? 79. So the charge will be positive 79. Question 34. There's a hydrogen isotope with the notation this, alright. You know that number of neutrons are 1. 2 minus 1 is 1. And protons is only 1, so the relative charge will be plus 1 only. Option A is the correct answer here. Now, question number 35. A radioactive source is placed near a detector. The radiation arriving at the detector from the source is measured for 10 minutes, and they're using different materials. All right. So the first material they used is nothing. They did not use anything. So the reading was 5626. All right. When they used a sheet of paper, the reading was nearly the same. All right. The thick sheet of aluminium, the reading significantly decreased, and when you used a thick sheet of lead, reading decreased even more. We know that the aluminum can reduce the number of beta particles, and the lead can reduce the gamma radiation, right? So beta and gamma must be the answer. Option C is the correct one here. Now, question number 36. The reading on a detector placed near a radioactive source is this much. Alright. The background count rate is 44. The half life is given, they're asking you the reading. Yeah. This is a good question. Just hear me out. It's a good question. So, see. The reading is 536. Now, this 536 is containing the decay along with the background count. Background count and decay is both are there. So let's only calculate the decay is how much. Decay will be background count minus the reading. So 536 minus 44. 536 minus 44 will come out to be 492. So this is the original decay of the radioactive isotope, right? Now let's make the first half-life of it. First half-life will be 34 hours. So then it will decay into half, which is 492 divided by 2, which is 246. Then another half life, another 34 hours. 246 divided by 2, it is coming out to be 123. So after 68 hours, the decay remaining is 136, 123, sorry. But now they're asking the reading on the detector. Just think about it. Detector will still count the background count, right? So 123 plus 44 you will have to do. The answer will come out to be 167. Next question. A planet is in the orbital solar system at point where the orbit is closest to the sun. When it is closest to the sun, the kinetic energy is the highest. You can just remember it like this, that if this is the sun and the planet is here, let's say planet A is here and planet B is here. Planet A will have high kinetic energy, less Gp, but the planet B far away will have more gravitational potential energy, which is Gp, less kinetic energy. So the closer you are, the more speed you will have. So the orbital speed will be at its maximum, the gravitational potential energy will be at its minimum. Option B is the correct answer. What is the main purpose that powers the sun? Main process that powers the sun? We know that the fusion of hydrogen powers the sun. So the fusion of hydrogen to produce helium powers up the sun. Option C is the correct. Now, question number 39. A galaxy is this much away from the Earth. At what speed is the galaxy moving away from the Earth? For this, we will have to use the Hubble's constant. H naught is equals to V by T. Now, they're asking us the speed, we know the distance, and we also know the Hubble's constant. Hubble's constant is 2.2 into 10 to the power minus 18 equals to V by D is 3 times 10 to the power 20. So it will be 2.2 times 3 times 10 to the power minus 18 times 10 to the power 20 is equals to the recessional velocity. And when you solve this, your answer will come out to be nearly 660 kilometers per second. Next question. An astronomer observes a distant galaxy. The table shows how the distance and the speed of the recession of the galaxy are determined. Alright. We know that the speed is determined by the change of wavelength. Right? So this and this we have to differentiate between option A and C. These two, in from these two we will get one of the answer, the our answer. Now we will use brightness of supernova in the galaxy. There is one reason to it. Supernova is something about whose brightness we clearly know. We are aware about the brightness of the supernova. That is why we will go with option A. Change in wavelength determines the speed, and the distance is calculated by looking at the brightness, the difference in brightness of a supernova, and now how it is looking. So that is why option A will be the correct answer. This is it, guys. We are done with the paper. And this paper was the IGCSE Physics May June 2024, the variant number 21. In case of doubts, make sure to let me know in the comment section. I'll be more than happy to reply.